So welcome to this lecture video. Here I am going to explain the experiment, that is laser diffraction. So here we are going to find out the wavelength of laser beam by the method of diffraction. So here we are going to pass laser light through grating and allow to fall the diffraction pattern on the screen, and by measuring the distance of the spot from the center we are going to calculate the wavelength of the laser light that we are using. Now let us go to the experimental part. This is the schematic view of this experiment. So this is a laser source, and here is a grating. This is a grating, and a screen which is kept at a distance 1 meter from the grating. So the distance between the grating and the screen is 1 meter. That is considered as capital D, and small d is the distance between the adjacent lines on the grating. Okay, so here small d is considered as grating constant, and the wavelength of the laser beam is calculated using this formula, that is 2d by m into xm by xm square plus d square whole to the power of half. Here xm is nothing but the distance of the spot from the center, and d is the grating constant, and m is the spot number, and capital D is the distance between the screen and the grating, that is kept as 1 meter. So this is what the experimental part. Now I am going to conduct the experiment by switching on the source. We will switch on the source. So switch on the source. Now you can see the diffraction pattern obtained on the screen. So you can observe the central spot is high intense in nature, and on both the side you are going to get the spots. So this is a central spot. So towards left as well as right, so many spots are available. The spot which is nearer to the central spot is spot number 1. This is spot number 2, spot number 3. Like that we are going to get up to spot 8. Similarly, this is a spot number 1 towards right side, spot number 2 towards right side, spot number 3, like this. So we have to mark all these spots by making use of pencil. So I will show you how to mark the points. A central spot, mark it, and then first spot, mark that. Similarly, second spot. Okay, so take the impression for all the spots on this graph sheet. Finally, we have to plot the graph as shown in the picture. So here this is a central spot, and here we are taken impression for first spot here, okay, and second spot here, okay, and third spot. So all those spots were all marked, and the distance of the first spot from the center O is observed to be distance of first spot. Now I am going to mark spot number 1, spot number 2, spot number 3, 4, 5, 6, 7, 8. So it is observed that the distance of spot number 1 towards left side from the central is observed to be 1.3 centimeter, and similarly towards right side it is observed to be 1.3. So equal distance that we can observe, and 2.7 second spot, and 2.6 towards right side, 4.1, 4.1, 5.3, 5.4, 6.8, 6.8, and 8.2, 8.2 towards right side, and 9.7 towards left side for 7th spot, and 9.7 towards right side, and finally 10.9 towards left side for 8th spot, and 10.8 towards right side for spot number 8. So like this we have to enter the readings, and by making use of this formula, you have to calculate the wavelength of laser beam. So here exam is nothing but the average of left and right side readings. That's what we are going to make. So for first part it is observed to be 1.3 into 10 to the power of minus 2 meter. Okay, so like this we can make. Similarly for second part it is 2.65 into 10 to the power of minus 2 meter. And if we use this formula and calculate the wavelength of laser, it is observed to be 6.603 into 10 to the power of minus 7 meter, or you can write it as 660 nanometer. So like this you can express. Similarly for second part it is observed to be 6.72 into 10 to the power of minus 7 meter. So like this we keep on entering the readings, and finally we have to calculate the average wavelength of laser beam that we are using. After the calculations, the readings were all coming like this, and the value of lambda is calculated in this format. It is observed that the average value of this is found to be 682 nanometer. So this is what the average value of wavelength of light that we are using. So this is the final answer. So like this you have to express the answer by showing the calculations and all. Thank you.